Hi class, this is section 3.5, overlapping triangles, and I'm going to do problem number 8 on page 139. I have it drawn out for you here. I need to prove that FG, which is this segment here, is congruent to JH. So my goal here is actually proving these overlapping triangles congruent first. And you see what I did right below is I separated these overlapping triangles. So can you picture FGJ separated, which I did down below, and JFH separated here down below. I want to prove these triangles congruent first, and then I can prove that parts of the triangles are congruent by CP/CTC. So, of course, we begin with our given. And the given is that angle 9 and 10 are congruent. So I'll draw in tick marks here. And angle GFH, so that's this angle here, is congruent to angle HJG. Okay. So my first step is what I see here, because they gave me angle 9 and 10 are congruent, I actually want to use my vertical angle definition, because vertical angles are those angles opposite made by two intersecting lines. So angle 9 and 11 are congruent because vertical angles are congruent. And the same reason goes for angle 12 and 10 being congruent. So that's what we can write next. Okay, so now notice how in the given I had angle 9 and 10 are congruent. And here I have 9 is congruent to 11, 10 is congruent to 12. So 9 and 10 are the same angle, and that is connecting angles 11 and 12. So now we can use axiom 1 in Euclid's Elements to say that angles 11 and 12 are congruent. So let's write that next. Okay, so next what I want to do is now I want to look at the angle GFJ. GFJ is right here. Oh, and I noticed that I forgot to put my tick marks in for angles 11 and 12. So I'm going to go ahead and do that. And I'm going to use the same tick mark for 9 and 11, because remember 9 and 11 were those vertical angles, and 10 and 12 are those vertical angles. So now all four of these angles are congruent. Okay, so what I was saying was I am going to now look at angle GFJ, which is the combination of these two angles, and then I'm going to look at angle HJF, which is the combination of those two angles. And so I'm going to use now the addition axiom, because these two are congruent. Angles 11 and 12 are congruent. So what I'm going to do is I'm going to add these two together to these two. And of course, we know that the wholes are congruent. That's axiom 2. Okay, so I've been writing a lot, but I haven't been putting tick marks on my two separated angles down here. So let's just go ahead and fill that in. I already proved that angle 11 and 12 are congruent. I just proved that angle GFJ by axiom 2 is congruent, I'll put 3 tick marks there, is congruent to HJF. Okay, now before I separated these two triangles, when they were together, notice they shared a segment, and that segment FJ. So I have FJ here and FJ here. Well, we know it's congruent to itself, right? And we use axiom 8 to justify that. So let's say that segment FJ is congruent to segment FJ by axiom 8. Okay, so hopefully you can see now that these two triangles are congruent. Well, we have to justify that. Notice it's by angle, side, angle. And once we do that, I can prove corresponding parts are congruent. So first say that triangle GFJ is congruent to triangle HJF. And we said it's by postulate angle, side, angle. And now I'm just about finished because remember we have to prove FG, which is this portion here, is congruent to JH. And since the triangles are congruent, their corresponding parts are congruent. So the justification is CP, CTC. So I can say segment FG is congruent to segment JH by CP, CTC. And that concludes our proof.